Now the students from Italy will show how Galileo developed the concept of relativity. Hello, Italy.
Good morning. Galileo Galilei was born in Pisa in 1544. He was an impetuous man and a bad student. He drops out the medicine faculty after 2-3 years and studies geometry of ancient on his own, Euclid and Archimedes. At the age of 23, he becomes professor of mathematics at Padova University. He loves fun and goes often to the taverns and places of pleasure. He has 3 legitimate daughters who becomes nuns. He doesn't go regularly to the church and doesn't confess, and he makes up the horoscopes for payment. As for the telescope in 69, he turns what in Holland was a toy into a scientific instrument, and he realizes its outstanding importance. After an initial model, he managed to improve it. He gets a great clarity of images thanks to a carefulness in the lens finishing, a perfect centering, and an exact distance. After that, he starts to observe the moon.
He discovered that it's different from all stars, with mountains and valleys opposing the Aristotelic theory. It orbits around the Earth, so the Earth, having the same composition of the Moon, is able to orbit around its center. In the 1609, he paints 6 watercolors of the Moon, and in 1610 he observes 3 little stars in a line parallel to the ecliptic, 2 in the east and 1 in the west, and the day after they are all in the west with a different position. He studies also the Venus and the Mercury's moon phases. They are similar to the moon phases until the full light of the disco, and they support the Copernican theory. Some spots are a further discovery to support the heliocentrism and the movement of the Sun on its own axis, and he writes, "And lastly, I give thanks to God for allowing me to be the revealer of marvels kept hidden in obscurity for all previous centuries." And this is a work collected in a library of Salerno.
Galileo Galilei proposed this reasoning. Imagine to be inside a boat. In this way, there is no reference to the outside world, and suppose the boat is quiet. Now imagine to make some observation, for example, to watch a drop falling into a bucket, or to throw a ball to our friend. The drop will directly arrive into the bucket, and the ball will directly arrive to our friend. Now imagine to be on the deck of the boat. In this way, you will be able to pay attention on the mean we are moving on. If we do the same observation, we will have the same result. Description of the same phenomenon from different points of view, which could appear with different characteristics to the watchers using a different coordinate system. Only an external point of view to the Earth one is capable to affirm that Earth is revolving. The speed of a point particle is a variable that is always relatively determined by a prefix coordinate system. The speed of the point P among two systems are linked to the simple formula v1 plus v. Speed of light, experiment. 2 people are on 2 different hills, 1.5 kilometers far from each other. Each one has a lantern and a drape. The first one uncovers the lantern and casts the signal. The second one sends a return back signal. If we know the distance and measure the time, hypothetically, it would be possible to size up the light speed. Unsuccessful experiment. The light just takes the 100th part of the milliseconds to cover the distance of 2 kilometers. That's a too short time to be calculated.
Accused of heresy for the belief that the Sun is the mobile center of the solar system and that Earth is not in the center and revolves, he was forced to abjure on the 22nd of June 1633. In 1638, completely blind, he wrote in a letter to his friend, "In my darkness I can quiet my disquiet brain." 1992, in a speech on the 31st of October, Jean-Paul II closed the Galileo affair, defining it a tragic and mutual misunderstanding, and he admitted the Church's fault. In fact, the Church recognizes the legal autonomy of the
of the science research and intends to settle all issues honestly and loyally. Bye.